Hi guys, and welcome to another Unity Houdini Devcast. This will be actually not a tutorial like the others. It will be more informational, and since I got a lot of questions after my first Unity Houdini Devcast about the destruction of the building, I decided to do this part 2, where I'm going to answer some of the questions and show you that what's the major power in using Houdini, and that is that actually programmers or the guys that use the procedural part inside Unity don't really need to have Houdini. Once you have a guys, which may be an external studio, for example, author these Houdini digital assets, you can then use them inside inside your Unity projects, and you don't really need to have Houdini running or anything. So I've decided to pack the asset inside the Houdini digital asset. So now, today I'm going to work inside Unity only and show you some of the features of the asset I just created. So let's start. Let's jump into Unity, and we are going to work only with Unity today. I decided to do something a bit different because I always try to experiment. So today we are not going to destroy buildings, but I created an asset that actually can create an object and then obviously destroy it. So this is not an asset that I just modeled in some 3D program or board. It's just created by the Houdini digital asset itself. So let me show you. We have this is the Houdini asset that you simply load once you have it exported from Houdini itself, and then you see all these inputs that we can create inside the digital asset. I already created a tutorial like a couple of years ago actually, where I'm talking about how to set up these inputs, but if you are interested in this as well, maybe I can do part 3, so just let me know. So these are the inputs that I just set inside Houdini, and I made them public from outside, so they are parameterized by the asset itself, so you can change them, and the Houdini engine then recalculates them and outputs the new the new result basically. We have a couple of inputs. First input is the curve that you can create by using the Houdini engine. There is a curve node that you can create, and then I use it as an input to, for example, to one of your digital assets. And then there is a second input for the fracture, which is a cube. Let's disable it for now. So what this asset does is takes a curve as an input, and then basically revolves it to create a vase, and then we are going to break down the vase. So let me show you the actual creation part. So let me move this. Oh, I just want to move this one, and let me show you. Since when I'm going to edit this curve, and you will see that the asset is actually created from that curve. We have this Houdini engine curve editor that you can use, and we have additional windows so you see what shortcuts do what. I actually know what a lot of them do, so let's just work on it a bit. I'm going to move it a bit, or not like this. I'm going to actually do it like a bit differently. So the inside part, this is the outside part. Let's move the curve back as well, so it's not as you know, so the base is so not so big. And as you can see, as I'm editing this curve, the object is changing. So you see it's generated in runtime by the Houdini asset. So we have this, I can disable it, we have these new ways. So you can basically generate your assets for a dungeon like this, and you will have a different basis that you can place inside the level like that. And then I also implemented, as I mentioned, the breaking part, so you can basically break it out inside Unity. You don't really need Houdini. That was one of the questions, and the thing that I was exploring, if it's possible to basically calculate a different frame from the Houdini simulation inside the digital asset, and it is possible. There is a special node in Houdini called time shift, where you can specify basically parameters to you can project to a frame inside simulation to a current geometry. So it's a really simple at the end. You can also specify the amount of parts, as I mentioned. So now these just 3 parts. You can really it brings a lot of randomization into your assets inside your game. So, and you don't need to model all these all these different assets for bases in different basically state of destruction. And then finally, as I mentioned, there is this. Let's break this like this. There is this input, the cube, and this input is called break volume. It's the thing that I showed you in the last tutorial at the last moment, and that is that you can actually specify which part of the vase should be broken down. So now I specify the volume by using a Unity mesh as an input. This is just a standard curve, a standard cube, the Unity cube. So I just specified that that part will be broken down. And again, I can specify this just this one, and then you can add more parts, and it will affect the constraints I showed in the last tutorial. Then I added a few debug views for this asset, so you can see what's going on. So, but by default, the output type is a final, which is what we want, which is the DC simulation and the broken down asset. But we can also see the constraints. So these are the constraints generated by the Voronoi cells. So, and you see how they are glued together. Then you can look at final constraints, and these are basically the constraints removed. The part of the constraints is removed by the cube, so you can see that this cube is removing the constraints it overlaps. So you will see which part will hold together and which part will fall off. And finally, there is one more debug view, and that is an exploded view, and it basically shows you all the parts of the mesh. So this is how the mesh parts will look out after the Voronoi. You'll see if you use the volume, for not all of them will fall apart, but they will still be there. They will be just glued together. So you will see how they you can preview if you are okay with this kind of parts. Then you go to the final and again just run simulation, so it will just fall off. And then you have this nice asset inside your dungeon, for example, with a broken vase. And there is one thing that if you change the fracture count, for example, or the volume or stuff like that, the simulation will be out of sync, as you can see. So you just need it to reset back and then simulate it again. And now you have this new vase. Similarly, if you change the curve, for example, it will revolve, it will update, but the parts, the simulation, the DOP network basically is cached, so the positions of the parts will be all over the place and stuff like that. You need to go to the first frame and then simulate it again. So guys, that's it. As you can see, that we have a authored Houdini digital asset that basically any guy that's working with or girl, obviously, in Unity inside your company can take this asset and use it inside Unity. He doesn't really need to know about Houdini, how to work in Houdini. He's just working with the parameters exposed by the graphics artist or the tech artist, and then just work with that. So I think this is pretty awesome. I mean, that's why I'm pushing a bit for Houdini to get it inside our company, but we'll see. To tell you the truth, it's kind of a steep learning curve for artists to learn Houdini. I have an artist background as well as a programmer's background. My programmer's background is a bit bigger than my artist background, and seriously, Houdini is playing straight to my programmer's background because I like to think in nodes. I like to think procedurally. I know what all the nodes do mathematically, and that's why I like to play with it. But if you are a bit on the creative side and you like to model and you using the UI for modeling and don't really want to think about the technical aspects, what's going on in the background, it may be a bit harder. But let me tell you, it's worth it. It's worth it to look into Houdini, and it's fun, seriously. So if there are any other questions about Houdini engine, Houdini assets, and how to use them in Unity, just let me know. Maybe I will do another tutorial or talk about the questions, and have fun. Thanks.